Name as many different forces as you can. Write this in your composition book and answer it. In this video, we're going to talk about forces. A force is a push or a pull on an object. Before we can really delve into forces, we need to understand the difference between mass and weight. Mass is the amount of matter in an object. The amount of matter in an object does not change depending on where the object is located. However, weight is the force of gravity on an object. Since the force of gravity can change, the weight of an object can change depending on the location of the object. Now we will look at the fundamental forces. All forces fit into one of four categories, from weakest to strongest. The first we're going to talk about is gravity, which would make it the weakest. Gravity is based on the concept that all masses attract each other. So there is a gravitational attraction between any two objects that have mass, like you and the person sitting next to you. In addition, gravity acts over long distances, like the sun's gravitational attraction holding the Earth in its orbit. The next fundamental force that we're going to look at is the electromagnetic force. It is stronger than the gravitational force. If you look at the root of this word, electro and magnetic, that reminds us of electricity and magnets. Both electricity and magnetism deal with things that either attract or repel. So electromagnetic forces are either attractive or repulsive. This includes electrical interactions, magnetic interactions, friction, adhesion, which is what makes tape sticky, collisions, elasticity, and chemical interactions. All of these forces fall under electromagnetic forces. The third force we're looking at is called the weak nuclear force. Now don't let that word weak fool you. It is a nuclear force, so it is dealing with atoms. It is the force responsible for radioactive decay, so it's actually pretty strong, at least compared to gravity and the electromagnetic force. Now the strongest of the four fundamental forces is the strong nuclear force. The strong nuclear force is exactly what it sounds like. It is a strong force that holds the nucleus of an atom together. So it's what holds the protons and the neutrons together in a nucleus. Now let's look at Newton's laws, some of the most famous work done with forces. Newton was very original. His first law is called, oddly enough, Newton's first law. Newton's first law is also known as the law of inertia. Inertia is the tendency of an object to resist a change in its motion. You've most likely heard this law stated as an object at rest remains at rest and an object in motion remains in motion at a constant speed in a straight line unless acted on by an outside force. Now let's look at that creative thinker's second law. Simply stated, Newton's second law says the acceleration of an object is directly proportional to the force applied to the object and inversely proportional to the mass of the object. If the acceleration is directly proportional to the force, that means if the acceleration increases, then the amount of force increases. If acceleration is inversely proportional to the mass, then if the acceleration increases, then the mass is decreasing. Mathematically, Newton's second law is written as F equals ma. And now for Newton's third law. Probably the easiest to remember. For every action, there is an equal and opposite reaction.